This talk presents experiences in Finland on creating a national cross-domain ontology and linked data infrastructure for digital humanities and using it on the semantic web. I am Eero Hyvönen from Aalto University and University of Helsinki, Helsinki Center for Digital Humanities. First, a few motivating words about the semantic web and linked open data. After that, I will discuss how to build a national linked open data infrastructure and use it in applications. This presentation is a kind of summary of 3 recent papers published in the Semantic Web Journal. The first paper is about the vision, using the semantic web in digital humanities, shift from data publishing to data analysis and serendipitous knowledge discovery. The second paper explains how to create a national cross-domain ontology and linked data infrastructure and use it on the semantic web. The third paper tells our experiences on using the infrastructure in practical work. We have created a series of portals and data services that have been used by millions of people. Digital Humanities on the semantic web, Sampo model and portal series. Digital humanities is a new research paradigm in the intersection of computer science, humanities and social sciences. Our research group develops and uses semantic web technologies and linked open data for digital humanities. Leonardo da Vinci has said, "Learn how to see, realize that everything connects to everything else." This wisdom is very true regarding cultural heritage data. However, cultural content linkedness gives us 2 major problems to tackle. The first key problem is that cultural heritage contents are richly interlinked, not only on a national scale, but across the borders of European countries and beyond. We all share common history and cultural background. For example, a book or epic may be the source of inspiration for a symphony, a painting, and is related to biographies of people, cultural sites, objects in museums, and so on. The cultural content includes texts, speeches, images, 2D and 3D models, movies and animations represented in incompatible formats using different national data models and using different natural languages. The second key problem is that cultural heritage content creation is distributed in different kinds of organizations. When independent parties create content independently from each other, the result is an avalanche of data silos that do not speak with each other. Our Sampo model to address these 2 previous key problems is depicted here. The idea is to establish a shared data and ontology infrastructure based on linked data. When a content provider creates a piece of content using the shared infrastructure, the data is automatically interlinked to and enriched by the other data provider's data, and their data by the new piece of content. In this business model, everybody can win. A key element in our approach is to use a shared infrastructure. Albert Einstein has said, "Intellectuals solve problems, but geniuses prevent them." This wisdom applies very well to infrastructure building. It's wiser to prevent interoperability problems before they arise than solve them afterwards when the damage has been done. For publishing datasets and data models, we created the Linked Data Finland platform. This system generalizes Tim Berners-Lee 5-star model of publishing linked data. You get the 6th star if you provide your data with a schema and documentation so that people can understand and reuse your data easily. You get 7th star if you validate your data and denote its provenance so that people can trust the quality of your data. This year, we extended the 7-star model with an additional 8th star for truthfulness of data. This star is given if the data publisher gives explanations when the data is factually correct with respect to the real world and when possibly not. How to use the infrastructure for applications, Sampo model and Sampo series of systems.
Science is vast, and so is the concept of AI. Though based on mathematical thinking, AI also has a lot to offer to social sciences through multidisciplinary approaches. For example, gathering of information. Very often, search engines give irrelevant or uninteresting results, or they can be out of context. The computer cannot comprehend what particular documents on the web are about. To provide more intelligent access for information, scientists have created the semantic web, where contents on the web are made comprehensible to the computer.
Another major benefit of the semantic web is that it can aggregate data from different data sources, even across language barriers. So we can get more data into the systems and in an interoperable way, so that people can be served with not only more intelligently the data, but also more data.
A worldwide pioneering semantic web concept has been developed in cooperation with the University of Helsinki and the Aalto University. It is a series of 12 semantic portals, each dedicated to a certain context. For example, the biography sample is a collection of over 13,000 biographies held by the Finnish Literature Society. These were transformed into a linked data service and enriched by linking it to the data of 16 external sources, such as Wikipedia, libraries, museums, and other archive collections. If you click on a particular biographical subject, you get a lot of interlinked, rich content about them. You can compare their lifeline on an interactive map, or you can select different life events from a list composed from different biography sources.
We have integrated the search and exploration systems with data analytic tools. So you not only get the possibility of search and explore the data, but also do data analysis and find interesting patterns of knowledge in the data.
For example, you can compare the places of birth and death of generals and clergymen in Finland in the 19th century and find out that generals moved a lot more than the clergy, who tended to remain in one place.
We're using artificial intelligence for solving problems. So not only do we provide the user with the tools for solving the problems, but we can provide him with artificial intelligence that can solve the problems by itself.
Since 2004, we have published over 20 linked open data services and semantic portals on the web based on the Sampo model. Culture Sampo publishes museum collections enriched by over 20 other types of data, including the narrative of the national epic Kalevala. Book Sampo, with its 1.6 million annual users, is a joint work with the Public Libraries of Finland with a focus on Finnish fiction literature. Biography Sampo is based on the biographies of the National Biography by Finnish Literature Society. Name Sampo contains some 2 million place names in Finland for toponomastic research. War Sampo is based on data from the National Archives, Defense Forces and others. It's a popular web service visited by some 1.2 million distinct users. Letter Sampo is joint work with Oxford University, Huygens Institute of the Netherlands, and Berlin Brandenburg Academy of Sciences on epistolary data research. Sampo publishes data from the Schoenberg Institute in Pennsylvania, Bodleian Library in Oxford, and IRHD Institute in Paris. It's about medieval manuscripts. Parliament Sampo publishes all million speeches of the Parliament of Finland, and Law Sampo, Finnish legislation provided by the Ministry of Justice. Opera Sampo is joint work with the Sibelius Academy. We have learned that linked data technology works like a Swiss knife to different kind of data sets. As a practical example of using a Sampo portal and a linked open data service, I will show a video about Letter Sampo, historical letters on the semantic web.
This video introduces the Letter Sampo project at the Aalto University and Helsinki Center for Digital Humanities Helsinki. We are developing a framework and a demonstrator for publishing and analyzing historical epistolary data in digital humanities based on semantic web technologies. This new project in Finland was inspired by our earlier collaborations with the Pan-European EU Cost Action Reassembling the Republic of Letters and the University of Oxford, related to historical letters sent from the 16th to 19th century in Europe and beyond. Letters are always sent from a place to another and are therefore scattered in different archives in different countries, written in different languages. Harmonizing the metadata from separate data silos and aggregating the data into a semantically interoperable global service for digital humanities analyses makes a nice use case for the Sampo model and Sampo UI framework, developed at the Semantic Computing Research Group. The SAMPO model includes a collaborative business model for collaborative data publishing in a shared linked data service, the idea of accessing the data from multiple perspectives, the idea of integrating the service seamlessly with data analytic tools for research, and finally, a model for addressing research questions in 2 steps, where faceted search is first used for filtering out data of interest, and data analysis and visualizations are then applied to it. We next illustrate this idea by showing examples on analyzing letter data by using the Letter SAMPO demonstrator. This is the main entry page for the Letter SAMPO user interface. The application consists of 3 perspectives to the underlying data: the actors, the letters, and the places. The underlying dataset in this example contains information about a total of 34,000 actors. By actor we mean an individual person or group of people like universities or religious organizations. In the faceted search we can filter or search specific actors by their name, gender, or times of birth or death, or groups of actors for prosopographical research. For example, we can search for the mathematician Gottfried Wilhelm Leibniz. On the result page we will see him among the other matches. The result table shows his years of birth and death, and the amount of the letters involved, based on the underlying metadata. On the person landing page we will have even more information about him and his correspondences. In addition to showing his basic biographical information, the page contains fields for his alternative names and vocations. There is a list of all the other actors with whom he has been in contact. It should be emphasized that any visualization or data analysis in a system like Letter SAMPO is an analysis of the underlying dataset, not of the real world. Any conclusions drawn from the analysis need source criticism and understanding the limitations of the data. For example, in this example there are 149 letters of Leibniz and the data misses lots of letters. Leibniz was a very active writer with some 15,000 letters and 1,100 correspondence. So in this case only 1% of those are available in the demonstrational dataset. In spite of this, analyzing an incomplete letter collection by distant reading can give novel insights to the researcher and collection manager, and suggest topics of interest for further close reading. The first person on the list is Christian Huygens, with whom he has sent 70 letters, as far as the data can tell us in this case. There are also detailed lists of all letters sent or received by him. The last result on this page shows a list of places he has been active and based on data about sending or receiving letters. The next tab, Network of Letters, shows a visualization of actors' egocentric network. The link width between 2 actors indicates the amount of mutual correspondence. The wider the link, the more letters has been sent between the 2 actors. We can for instance spot that Leibniz sent 39 letters to Christian Huygens, while Henry Oldenburg sent more than 200 letters to Huygens. Again, this analysis is based on data about only a fraction of Leibniz's known letters. The next tab illustrates the number of letters on a timeline, where we can observe that the data is based on letters from 2 periods, the first one in the 1670s, and the second in the 1690s. This could indicate the collection manager that letters in between may be missing. The letter perspective page has a similar faceted search application as the actor page. Here we can browse and filter the data of 162,000 letters by their sender, receiver, date, language, subject, or data source. The second tab on the letter page visualizes the letter routes on a map application. Currently we are viewing the routes of letters sent from Paris. The third tab on the letter page demonstrates the amount of correspondences on a timeline. From this curve can be seen that the data is distributed from 16th to 19th century, with the majority of letters in the 17th century. In addition to the ready-to-use data views in Letter SAMPO, the underlying SPARQL endpoint can be used easily for further data analyses using, for example, Python scripting in Google Columns. This data table shows the most active mathematicians in the data set, filtered out from the data. The left column shows the actors ranked by the number of letters sent. In the middle column ranking is based by the number of received letters, and on the right by the total amount of letters. The blue text color indicates that the actor has written more letters than what he has received. This is a visualization of the top writers between the years 1620 and 1770, and the ranking of the author is depicted on the y-axis, so that the highest ranking actor appears on the top of the diagram. Based on the underlying collection data, in the 1620s and 1630s Marin Mersenne was at the highest rank. Christian Huygens was among the top writers during the years 1650 to 1690s. Isaac Newton has been an active writer in the late 17th and early 18th century. And finally we have Leonard Euler, who's been the top writer during 4 decades from 1730s to 1760s. Thank you all for watching this video. More information about the Let SeCo project is available at the web page of the Semantic Computing Research Group.
Summary. Lessons learned. This timeline summarizes our work on building and applying the national semantic web infrastructure in Finland in relation to major international developments and phases, where ontologies, the silver bullet of the semantic web, were first in focus. After that, ideas of linked data publishing took off, and during the last 10 years, ontologies and linked data have been studied together as knowledge graphs in various domain-specific application settings. We are now entering the time of AI and neurosymbolic intelligent systems. The work in Finland has followed exactly the same pattern with major projects such as FinOnto for ontologies, Linked Data Finland for linked open data, and various sample projects on knowledge graphs. Also, first steps towards knowledge discovery and AI have been taken. All work has been based on standards and best practices of W3C and others illustrated at the bottom. We have learned that it really makes sense to develop a linked open data infrastructure together with the stakeholders such as data owners. After each step, the infra from the previous steps can be reused in new applications and being developed further. Linked open data infra is also very resilient for different application domains, as illustrated by the sample series of specific systems. We have also learned that it's very important to make application development easy in order to keep the funders and the end users happy. For this purpose, we developed the Sampo UI framework. The idea there is to reuse a kind of standard interface model and logic. This means that the model and the systems are easy to learn by users and easy to be used by developers. The idea is to base application on a simple linked data service API, the Sparkle. The software is openly available in GitHub and it has been used by various groups in addition to us. The Sampo series presented demonstrates a paradigm shift in 4th generation of publishing data for humanities. First, there were engravings in tombstones, clay tables, and so on. Then came printed texts. Online systems for searching and exploring the contents of databases became popular in the 90s. With linked data, we entered the era of publishing data on the web. So we are not only publishing human-readable texts, but also the underlying data that can then be used for applications and data analysis. This is the main area of the Sampo series. We have integrated seamlessly data analytic tools with search and exploration systems. Now we are also entering the 4th phase, automatic knowledge discovery and artificial intelligence. The idea there is that the machine, based on linked data and other data sources, can automatically discover interesting patterns of knowledge in the data, propose the human user new research problems, and even solve the problems with explanations by using artificial intelligence technologies. In Douglas Adams' novel, The Hitchhiker's Guide to the Galaxy, the computer was asked, what is the meaning of life, the universe, and everything? The answer, 42, may be right, but it would be nice to know also why. This illustrates that explainable AI is needed for humanities research, and I think that symbolic linked open data is one way to go. More information about the research presented can be found on the homepages of the Semantic Computing Research Group.